For the Chapter 3 review sheet, we first want to use synthetic substitution to evaluate f of 4 for f of x equals 2x to the fourth minus 3x squared plus 5x minus 15. So we can use synthetic substitution instead of actually taking 4 and plugging it into the function to find out what f of 4 equals. So I'm going to put 4 on the outside of the division box. And then on top, I'm going to put all of the coefficients. So I have a 2. And then since I'm missing an x cubed, I'm going to fill in a 0. And then a -3 and a 5 and a 15. So now for synthetic substitution, I'm first going to drop down the 2 and then multiply. And then add. And 4 times 8 is 32. And then that would be a 29. And 4 times 29 is going to be 116. So then that would be a 121. And then 4 times 121 is 484. And then plus 15 would be 499. So 499 is what f of 4 would equal. Another way to evaluate f of 4 is to just plug it in to the function. So we have 2 times 4 to the fourth minus 3 times 4 squared plus 5 times 4 minus 15. 4 to the fourth power is 256. And 4 squared is 16. And that would be plus 20 minus 15. So 2 times 256 would be 512. And 3 times 16 is 48. And then 20 minus 15 is plus 5. So I have 517 minus 48. And that would give me 469. So let's see if we made a mistake above, because we should get the same answer. So I'm going to go back to number 1 and see if I made a mistake with any of my math. Oh, I see my mistake. This 15 should have been negative. There we go. So then 484 minus 15 would be, let's erase the 9 right there, 469. So that's kind of a good way that you can check your work. All right. Number 3 is draw Pascal's triangle to the 7th row. So Pascal's triangle starts with a 1 on the very top, but this is considered row 0. So now to get the rest of our rows, we do another 1 and another 1. And then we always start our row with a 1, and then we add the 2 numbers above. So in this case, it'll be a 2. So I'm going to write a 2 down below it, but in the middle, and then we end with a 1. So my third row is going to be a 1, a 3, a 3, and a 1. My fourth row is 1, 4, 6, 4, 1. My fifth row is 1, 5, 10, 10, 5, 1. My sixth row is 1, 6, 15, 20, 15, 6, and 1. And then my seventh row is going to be 1, 7, 21, 35, 35, 21, 7, and 1. And that is Pascal's triangle to the 7th row. Next, we want to add and subtract and multiply and expand some polynomials. So to add two polynomials together, all we need to do is combine like terms. So I have a 5x cubed and a 1x cubed, so that will give me a 6x cubed. And then I have just a minus 9x squared, and there's nobody to combine that with. And then I have a minus x and a positive 4x, so that'll be a positive 3x. And then I have just a plus 3, so he'll be in the back. When we're subtracting polynomials, we want to take the negative and distribute him before we subtract. So we have x cubed plus 4x squared minus 5x minus 4x cubed minus x squared plus 7. So that will give me a negative 3x cubed plus 3x squared minus 5x plus 7. For number 6, we're multiplying x minus 6 times 5x squared plus x minus 8. So for this one, we want to first distribute the x to everybody and then distribute the 6 to everybody. So if I distribute the x, that will give me 5x cubed plus x squared minus 8x. And then if I distribute the negative 6, I'll get negative 30x squared minus 6x plus 48. Then I just need to combine my like terms for my final answer. So I'll get 5x cubed minus 29x squared minus 14x plus 48. For number 7, we have 3x minus 1 to the 4th power. Now we have two choices. We could either write this out 4 different times and then FOIL all of that together, but that would take a really long time. A better way to do it is to use the 4th row of Pascal's triangle because we're raising it to the 4th power. And the 4th row is 1, 4, 6, 4, and 1. And you can just refer to the Pascal's triangle that we did before this. And those will be the coefficients to our terms when we expand it. So first I'm going to use a 1. And then I'm going to use my first term, which is 3x, and raise it to the 1st power. And I don't need my second, oh, I'm sorry, to the 4th power. There we go. And I don't need my second term yet. Now, since it's subtraction, I need to alternate between positive and negative. So now I'm going to have a minus 4 from Pascal's triangle. And then I'm going to have a 3x to the 3rd, because these exponents go down. And now I'm going to have times a 1 to the 1st. So we always use our b value in our second term. Now I'm going to use my coefficient from Pascal's triangle, which is now going to be a positive 6 since we're alternating. And then I'm going to have a 3x squared and then a 1 squared. Then my next term will be a 4, but I need to make it negative. And then I'm going to have a 3x to the 1st and a 1 to the 3rd. And then finally, my last term will be a plus 1 and then a 3x to the 0, which will just be 1. And then that will be multiplied by a 1 to the 4th. All right, and so now I'm ready to multiply everything together and then simplify it. So for my first term, I have 1 times 3x to the fourth, which would be 81x to the fourth, because the fourth needs to affect the 3 and the x. My second term will be 4 times 27x cubed times 1. So I'll have to go back and multiply that out. My third will be 6 times 9x squared times 1 squared. And then I will have just a minus 12x and then a plus 1. So then for my final answer, I will have 81x to the fourth, and then 27 times 4 is 108, so minus 108x cubed, plus 72, 56, 54. Multiplication is hard. So there we go, 54x squared minus 12x plus 1. Now we're going to move on to factoring. And first we're going to factor sum and difference of cubes. So when we factor sum of difference of cubes, we want to remember the pattern. And the pattern is SOAP. And if we're factoring a difference of cubes, we'll have a minus b, because we do first the same sign, and your a and your b are whatever is being cubed in the beginning, times a squared plus ab plus b squared. And we go same sign, opposite sign, always positive. So if it is a sum of cubes, then we'll have a plus sign first and a minus sign second. So for 64x cubed minus 1, we first want to figure out what our a and our b are. What are the two things being cubed? So if we look at 64x cubed, that is the same as 4x cubed, since 4 cubed is 64. And then a 1 is just the same as 1 cubed. So our a is 4x and our b is 1. So now we just need to plug it into our pattern. So we'll have first a 4x minus 1. That's our a minus b. And then we'll have an a squared, which will be 16x squared. You have to square the 4 and the x. And then ab is just whatever b times a is, which will be plus 4x. And then b squared would just be a plus 1. For 8x cubed plus 27, we're going to do the same thing. So 8 is 2 cubed. So our a will be 2x, and 27 is 3 cubed. So our first factor will be 2x plus 3. And then our second factor will be a 4x squared. This time we'll do a minus because we need the opposite sign. So minus whatever 3 times 2x is, which is 6x, plus b squared, so plus 9. And once you factor using the sum or difference of cubes pattern, you're done. You don't have to factor further because the last factor is never factorable. With number 9, we first want to factor out a greatest common factor before we completely factor it. So it looks like that we can first factor out a z. So I'm going to factor a z out. So I have z squared minus 4z plus 4. And then we want to ask ourselves the question, CIFM, can I factor more? And the answer is yes. So I'm going to have a z minus 2 and a z minus 2. So we could either leave the answer like that, or if you want to be fancy, you can leave the answer as z times z minus 2 squared. For part B, we can first factor out a 3 and then also a y cubed. So that will leave us with a y squared minus 16. And then we can factor more. So we have a y plus 4 and a y minus 4. For number 10, we are going to practice factoring by grouping. So when we factor by grouping, we first look at the first two terms and see what we can take out of those. And this time I can take out an x squared, and I'm left with x minus 3. Then we look at the second two terms, and I can take out a negative 4, and then I'm left with an x minus 3. When you factor by grouping, you have to get the same thing here and here. If you don't, factor by grouping does not work. So if you do get the same thing, then we can take the two terms that are on the outside, x squared minus 4, and put it with one of the x minus 3's. Then we have to ask ourselves the question, CIFM, can I factor more? And we can. So we have x plus 2, x minus 2, and then x minus 3. For part B, it looks like that we can take out an x squared, and we're left with 2x minus 7. And then we can take out a negative 4, and we're left with a 2x minus 7, which is good because we got the same thing. So now I have x squared minus 4 times 2x minus 7, and we can factor more. So we have x plus 2, x minus 2, and 2x minus 7. For part C, we can take out an x squared, and we're left with x plus 4. And for the second two terms, we can take out a negative 1, and we're left with x plus 4. So then we have x squared minus 1 times x plus 4, and we can factor more. So we have x plus 1, x minus 1, and x plus 4. In number 11, we're going to first factor into quadratics, which means that your factors will have x squareds in them at first. So if we look at x to the 4th minus 13x squared plus 30, we're going to factor it just like normal, except instead of just having x's, we're going to have x squareds, since x squared times x squared gives you an x to the 4th. So now we want to think of two numbers that multiply to 30 but add to negative 13, and that would be a negative 10 and a negative 3. And then we want to ask ourselves the question, CIFM, can we factor more? And in this case, we have a difference, but it's not a difference of squares. So you could leave the answer like this, or you could pretend that 10 is the square of the square root of 10 and factor it like this: x plus root 10, x minus root 10, x plus root 3, and x minus root 3. So either answer is okay. For part B, we want to first factor out a 2x, and then we'll have an x to the 4th minus 6x squared plus 5. Then we want to see if we could factor that more, and we can. We can factor that into x squared minus 1 and x squared minus 5. And we can factor x squared minus 1 into x plus 1, x minus 1. And then if you would like, you can factor x squared minus 5 to x plus root 5 and x minus root 5. For letter C, we can first factor out a y. I think that's the only thing we can factor right off the bat. And we'll have 16y to the 4th minus 81. And then we'll notice that those two numbers are a difference of squares. 16y to the 4th is the square of 4y squared. So we can factor that to 4y squared minus 9, and 4y squared plus 9. And then we see that 4y squared minus 9 is a difference of squares. We cannot factor further 4y squared plus 9 because it's a sum of squares. So we will factor 4y squared minus 9 to 2y plus 3 and 2y minus 3. And then we still have 4y squared plus 9. Now for 12 and 13, we want to factor and then solve for the zeros or the solutions of the polynomial. So since we have 12 terms for number 12, we want to factor by grouping. I'm sorry, 4 terms for number 12. So I'm first going to factor out a g squared, and then I'll have a g plus 3. And then I can factor out a negative 1, and I'll have a g plus 3. And so then I'll have a g squared minus 1 and a g plus 3. And then I can factor g squared minus 1 further to g plus 3, g minus 3. I'm sorry, g plus 1. There we go. G minus 1. And then g plus 3. So now I want to take each factor and set it equal to 0. And then I'll note that my 3 zeros are negative 1, 1, and negative 3. And it would make sense that we have 3 zeros because we have a third degree polynomial. For number 13, looks like I can first factor out a 2y squared. And then I'll be left with 4y to the 4th minus 19y squared minus 5. And then I want to see if I can factor 4y to the 4th minus 19y squared minus 5 even more. And I'm going to factor it. I need a 19 in the middle, and I see I have a 5, and 4 times 5 is 20. So I'm going to factor it with a 4y squared over here. Then I'm going to put a 5 over here, since if I FOILed that out, that would make a 20. And then I'm going to put a 1 here and a y squared here. So if I did the smiley face method, I would need a negative and then a positive. If I did the smiley face method, I should get a negative 20y plus a y squared, which would give me a negative 19y squared. Okay, so now I am ready to set each piece equal to 0 and solve. So I have 2y squared equals 0, 4y squared plus 1 equals 0, and y squared minus 5 equals 0. So if I solve 2y squared equals 0 and divide by 2, I get y squared equals 0. So y will equal 0, but that will have a multiplicity of 2 since it was a y squared. For the next piece, 4y squared plus 1 equals 0. I'm going to subtract 1. So 4y squared equals a negative 1. Divide by 4. And then I notice that if I square root negative 1/4, I'm going to get imaginary solutions. And before, we were only asked to find the real solutions. So we can stop. We don't have to keep going on that one. For y squared minus 5 equals 0, I'm going to add 5 to the other side. Square root both sides, so I'll get y equals plus or minus the square root of 5. So my 3 answers would be y equals 0 with a multiplicity of 2, and y equals plus or minus 5. Now we want to find all of the solutions of the equation, including the imaginary ones. So for 14, I'm first going to factor out a z to the 4th, and I'll be left with a z minus 3. Then I'm going to factor out a negative 16, and I'll be left with a z minus 3. So I'll have z to the fourth minus 16 times z minus 3. And I can keep factoring. So I'll have a z squared minus 4 and a z squared plus 4 and a z minus 3. And I can factor even more to z plus 2, z minus 2. I can't factor z squared plus 4 anymore, so I'll just leave it. And then I have a z minus 3. So now I want to take each piece and set it equal to 0. So z plus 2 equals 0, z minus 2 equals 0, z squared plus 4 equals 0, and z minus 3 equals 0. So z will equal negative 2, equal positive 2. For z squared plus 4 equals 0, z squared will equal negative 4. So when I take the square root of that, I will get plus or minus 2i, and then z will equal 3. So I ended up getting 6 solutions. 1, 2, 3, 4, I'm sorry, 5 solutions. 5, because I had a 5th degree polynomial. For number 15, I'm going to first factor out, looks like all I can factor out is a c squared. And I have 18c squared plus 57c minus 10 equals 0. And now I need to see if I can factor further. Hopefully I can. So I am going to see if I can factor this with a 6c and a 10 over here to make 60. And then I'll have a 3c and a 1 to make 57. So let's see. So that'll be a plus and a minus. So it looked like that worked. Okay, so then I want to take each piece and set it equal to 0. So c squared equals 0. 6c minus 1 equals 0. And 3c plus 10 equals 0. So c will equal 0, and that will have a multiplicity of 2. And c will equal 1/6, and c will equal negative 10/3. For number 16, we want to divide 4x to the fourth plus 29x cubed plus 4x squared minus 14x plus 37 by x plus 7 using synthetic division. So we're allowed to use synthetic division anytime we have a binomial. If we have a trinomial like we have down here, then we have to use long division. So to use synthetic, first I take x plus 7, set it equal to 0, and I get x equals negative 7. So negative 7 is going to be the number that I put outside of the division box. And now I'm going to put all the coefficients on the top. So I have a 4, a 29, a 4, a negative 14, and a 37. And now I'm ready to do synthetic. So I've dropped down the 4, and I get a negative 28, and then a 1, a negative 7, a negative 3, a positive 21, a 7, and then a negative 49, which will be a negative 12. And negative 12 is the remainder. So now for my final answer, I'm going to write all of my coefficients into a polynomial. So I have 4x cubed plus x squared minus 3x plus 7. And since negative 12 is my remainder, I'm going to do a plus negative 12 over what I was originally dividing by, which is x plus 7. For number 17, for long division, I'm first going to write 3x squared minus 3x plus 2 on the outside of my division box. And on the inside, I'm going to write 6x to the 4th. And since I'm missing an x cubed, I'm going to write plus 0x cubed plus 7x squared plus 4x minus 17. And the first thing I do is I say, what do I have to multiply 3x squared by to get 6x to the 4th? And that would be a 2x squared. And then I take my 2x squared and I'm going to distribute him to each number. So I have 6x to the 4th minus 6x cubed plus 4x squared. And now I want to subtract my two polynomials, but instead I'm going to change the signs. That's a little bit easier. And then add them together. So I have 6x cubed plus 3x squared. And then I'm going to drop down the 4x. And now we do it all over again. So I'm going to say, what do I need to multiply 3x squared by to get 6x cubed? And that would be a 2x. And then I'm going to multiply 2x by everybody. So I get a 6x cubed minus 6x plus 4x. And then I'm going to change all the signs. So I'm left with a, oh, this is a squared. So I'm left with a 9x squared plus 0x, and bring down the negative 17. And then we do it one more time. So we have to ask ourselves, what do I need to multiply 3x squared by to get a 9x squared? And that would be a positive 3. Then multiply, so I get a 9x squared minus a 9x minus or plus 6. And then we change all the signs. And I end up with a 9x minus 23. And since 9x minus 23 is a smaller degree than what we were dividing by, he is my remainder. So I'm going to do a plus sign and do 9x minus 23 over what we were originally dividing by, which was 3x squared minus 3x plus 2. And then that is my final answer. For number 18, we're going to factor x cubed minus 5x squared minus 2x plus 24 completely, given that x plus 2 is a factor. So since x plus 2 is a factor, I know that if I plug in a negative 2, I should get a 0. So we'll do synthetic division and put the coefficients up on top. And we get a 1, a negative 2, a negative 7, a 14, a 12, and then a negative 24. So now I'm going to take my remaining coefficients and write them as a polynomial. If I factor that polynomial, I'm going to get x minus 3, x minus 4. And then x plus 2 is my original factor. So I'll put that next to that. And that will be my final answer. So 19 we're going to do into a similar way, except they said that 8 is a 0, which means that I can just put 8 outside of the division box. And then do synthetic. and synthetic works. Get a 0. So now I'm going to take x squared minus 3x minus 10 and factor him further. So I get x minus 5 and an x plus 2. So my zeros are x equals 5 and x equals negative 2, and then also x equals 8 since I was given that in the beginning. Number 20 is very similar, so we're going to put a negative 6 on the outside, and then a 2, a 7, and a negative 33, and a negative 18. And then I get 2x squared minus 5x minus 3, and I'm going to factor that further. And I'm going to do a negative 3 to get a negative 6 and a positive 1. So my other zeros look like it will be a negative 1/2 and a 3 and then negative 6 since I started out with that in the beginning. For number 21, we want to first find the possible zeros of f of x equals x cubed plus 6x squared plus 5x minus 12. So since we have a 12 as our constant, our possible rational zeros are going to be the factors of 12, which are 1, 2, 3, 4, 6, and 12. And we want to use plus or minus because they could be positive or negative. Now for 22, we want to use those possible rational zeros to find all of the zeros of the function. So I am going to first see if 1 is a 0 by testing it with synthetic division. And it doesn't look like it is because I don't get a remainder of 0. So now I'm going to try a negative 1 and see if negative 1 will be a 0. Oh, that didn't work. But I think I didn't do it with a negative 12 before. Let's see. Let's try it with 1 again. See if I made a mistake the first time. So if I do that, I have a 1, a 7, a 7, oh, that does work. Okay, never mind. So 1 works. 1 is a 0. So now I'm going to take x squared plus 7x plus 12 and factor him further, and I get x plus 3 and x plus 4. So my other two zeros are a negative 3 and a negative 4. For 23 and 24, we're given the roots of a polynomial, and we need to write the polynomial function with the given roots. So we know that one of the roots is 4, and another one is 1 plus 5i. And if 1 plus 5i is a root, we also know that 1 minus 5i has to be a root. So we're going to first write the roots in their factors. So the first factor is x minus 4. The next is x minus 1 plus 5i. And then x minus 1 minus 5i. And now we need to FOIL our factors together. So we learned a trick to FOIL x minus 1 plus 5i and x minus 1 minus 5i. We're going to FOIL x minus 1 times x minus 1, and then plus 5i times negative 5i. And we get x squared minus 2x plus 1 minus 25i squared. And we know that I squared equals negative 1, so this will be x squared minus 2x plus 26, since we'll get a positive 25. But we still have to FOIL that with the x minus 4. So when we do that, we'll get x cubed minus 2x squared plus 26x minus 4x squared plus 8x minus 4 times 26, which is 104. So our polynomial will be f of x equals x cubed minus 6x squared plus 34x minus 104. Number 24 is very similar, except if we have 3 minus root 5 as a root, we also must have its conjugate, 3 plus root 5, as a root. So our first factor will be x plus 2. Our second will be x minus 3 minus root 5. And our third will be x minus 3 plus root 5. And the same trick that we used in 23 will also work in this one. So we will first FOIL x minus 3 times x minus 3 together, and then add negative root 5 times positive root 5. And that will be x squared minus 6x plus 9. And then negative root 5 times a positive root 5 is just a negative 5. So we get x squared minus 6x plus 4. And then we still have to FOIL that with the x plus 2. So we'll get x cubed minus 6x squared plus 4x plus 2x squared minus 12x plus 8. So our final function will be x cubed minus 4x squared minus 8x plus 8. For number 25, we want to identify whether or not the functions are polynomials. And a polynomial must have exponents that are natural numbers or whole numbers. And it must have real coefficients. And A satisfies... Oh, nope. A has a P in it. I don't know if it was supposed to have a P. I think that might have happened during the transfer. So let's change that P to a 2. And then it would have real coefficients. So yes, it would be a polynomial. And for g of x is not a polynomial because of this negative 1 exponent and this variable as an exponent. So that would be a no. For number 26, we want to describe the end behavior of the functions. And we want to make sure that we double check that they are in standard form. And they all look like they are because the highest exponent is first. So for A, we have a negative leading coefficient and an odd exponent, which means that the arrows will go in different directions, but it will start up and end down. So it rises left and falls right. And for part B, we have a negative leading coefficient and an even degree. So both ends will go down. So it will fall left and right. For part C, we have an odd degree and a positive leading coefficient, which means that it will start down and end up. So it falls left and rises right. And for D, we have a positive leading coefficient and an even degree, so both ends will go up, so it will rise left and right. For number 27, we want to graph the polynomials, and to do that, we first want to find the zeros. And they're already in factored form, so we know that for A, our zeros are going to be at 1, 2, and at 3. So I'm going to graph those zeros at 1, 2, and 3. Next, we want to know what the end behavior is of the graph. So since we have 3 zeros, we know that we have an odd degree, and the leading coefficient is positive. So my end behavior is going to start down and end up. And the last thing I want to find is the y-intercept. And we find the y-intercept by plugging in 0. So I'll have 5 times negative 1 times negative 2 times a negative 3, which will give me a negative 30. So y-intercept way down here at negative 30. And with those 3 pieces of information, we should be able to draw our graph. So I'm going to come through negative 30, and then up through my first x-intercept. We don't know how high up to go yet, so we can just kind of turn around whenever, down, and then back up. And there is my first polynomial. For B, we have zeros at 0, 4, but since that is squared, we're going to have a multiplicity of 2, which means we'll form a parabola at that point of the graph, and negative 1. And since that has a multiplicity of 3, we'll form a sigmoidal at that point. So I'm going to put those 3 zeros on my graph. Okay, and then we need to do the end behavior. So the degree of this is really 6, since I have a degree of 1 here, or I'm sorry, an exponent of 1 here, 2 and 3. We want to add those all together. And since he's negative, both of my arrows will be going down at the end. And then the final thing that I want to find is my y-intercept. So if I plug in 0, I'll get a 0 times negative 4 times 1, negative 4 squared times 1 cubed, but that will just be 0. So now I'm ready to graph. So I'm going to go through, negative 1, but I need to go through it like a sigmoidal since that has a multiplicity of 3. I'm going to redraw my arrow a little bit. So I'm going to go through it like that. And then 0 has a multiplicity of 1, so I just need to turn around and go through 0 like normal. And then 4 has a multiplicity of 2, which means I need to come up to 4, form a parabola, and turn back around. And there would be the graph of B. For 28, we need to graph the polynomials on our graphing calculator and then find the zeros and the relative maxima and minima. So for our first function, 2x cubed plus 8x squared minus 3, it looks like we have 3 zeros and 1 local maximum and 1 relative maximum and 1 relative minimum. So to find the zeros, you want to make sure you go to Second Calc and the 0 feature, and then make sure that your little cursor is first to the left and then to the right, and hit enter. To find the maximum, make sure you go to Second Calc and select maximum, and make sure that you actually find the maximum first, and that should come out to negative 2.667 and 15.963. When I first graphed it, I needed to change my window because I couldn't see the whole graph. So I changed my y max to 20 so I can see the entire graph. And then to find the minimum, again, you go to second calc and select minimum, and then put your spider to the left and the right. And when I did it, I got 7.6837 e to the -7th. That really means 0 because that's in scientific notation. So the minimum should be 0, -3. For part B, I graphed the function and noticed that I couldn't see the whole graph because I only saw 3 x-intercepts, and I knew that this graph should have 4 because it was to the 4th power. So I changed the window and I put my x max at 15, and then I was able to see the whole graph. And even though we can't see one of the minimums, because there would be a minimum down there somewhere, we can still see one of them, and we can see a max, and we can still calculate the min even though we can't see it. So to calculate the zeros, again, you want to go to second calc 0, and there's going to be 4 of them, 1, 2, 3, and 4. And then we have one maximum right here, and then we have 2 minimums, one right here and one down there. So you can just do a left bound and a right bound where you can see it, and then it should calculate the minimum for you. For number 29, we want to state the degree of the polynomial. So since a is a monomial, we add up all of the exponents to get the degree. And so since we have a 3 plus a 6 plus really a 1, the degree would be 10. For b, we just have a constant with no x's or any variables, so that degree is 0. And for c, we have a regular polynomial, and so we use the highest exponent, so that degree is 3. For the concept review, if 1 plus root 3 is a solution to the polynomial, so is 1 minus root 3, since we need to have conjugates if we have radicals. A relative maximum of a graph occurs when the graph changes from increasing to decreasing. So the graph goes up, and then it turns around and goes down. And a relative minimum of a graph occurs when the graph changes from decreasing to increasing. True or false? A graph can have more than one relative minimum. That is definitely true. We saw that in our last graph that we did on the graphing calculator. If 2 minus I is a solution to a polynomial, so is its conjugate 2 plus I. The degree of a polynomial indicates the number of solutions or zeros or roots. You can use any of those numbers. I'm just going to use zeros. Number of zeros of a polynomial. The end behavior of a polynomial is determined by the degree and the leading coefficient of the polynomial. What is the acronym we can remember to factor difference or sum of cubes? And that is SOAP. Same sign, opposite sign, always positive. A 0 with an even multiplicity forms a parabola at the x-intercept, or the x-axis. If you are asked to find all of the real zeros of a polynomial function, we do not need to find the imaginary or complex solutions of a polynomial. Does the degree of the polynomial always match the number of x-intercepts? That is no. And that is because we can have multiplicities. So if we have multiplicities in a polynomial, then the degree will not be the same as the amount of x-intercepts, but it will be the same as the number of solutions that we get.